Number 1. The Chinese Submarine 361. There is a kind of death at sea that leaves no wreckage, no fire, and no warning. In the middle of April 2003, a Chinese submarine slipped beneath the surface of the Yellow Sea to run a routine training exercise. It was hull number 361, a Ming-class diesel-electric boat, a Chinese descendant of an old Soviet design. Aboard were 70 men. Not one of them would survive the day, and the boat itself would come back untouched. Picture the scene inside. To recharge her batteries, a diesel submarine must run her engines, and to run engines she needs air, drawn down through a snorkel mast. On board 361, something in that air system failed. The intake did not admit fresh air the way it should have. The diesel engines, still running, kept pulling oxygen from inside the hull itself. In the span of perhaps 2 minutes, the engines breathed the crew's air faster than the crew could. There was no explosion. There was no flooding. There was only a silence that spread compartment by compartment as men slumped at their stations. The boat did not sink. She hung in the shallow water off the Nechingshan Islands, drifting, her crew already gone. No distress call was ever sent because there was no one left awake to send one. Days passed. Then, around the 25th of April, fishermen noticed a periscope standing above the waves where no periscope should be. When rescuers finally opened the hatches, they found all 70 men dead where they had fallen. The interior perfectly preserved, the machinery intact. The scale of the loss forced a rare public admission. On the 2nd of May, Chinese state media announced the disaster, and the fallout climbed to the top of the Navy. The commander of the fleet, Admiral Shi Yunsheng, and his political commissar were both removed from their posts. It remains the deadliest peacetime submarine disaster in Chinese history. Investigators believe the crew were carrying extra trainees, which is why so many were aboard. What makes 361 so haunting is how ordinary the killer was. Not a torpedo, not the crushing deep. A mechanical valve, a governor that failed to shut an engine down. The submarine was later refit and returned to service, a decision that drew quiet criticism given what had happened inside her. She is studied to this day as a warning about the danger of running diesels while submerged, and it raises a question that runs through every story here. What happens when the ocean claims a crew, but never bothers to claim the boat? Number 2. The Pisces 3 rescue. If 361 shows how fast the sea can take a crew, this next story shows how close it can come and still let go. On the 29th of August, 1973, a small submersible called Pisces 3 was working about 150 miles southwest of Ireland, burying transatlantic telephone cable on the seabed. Inside were 2 men, pilot Roger Chapman and engineer Roger Mallinson, folded into a personnel sphere barely big enough to sit in. As the submersible was being recovered, a rear compartment flooded. The added weight dragged Pisces 3 backward off the surface and sent her plunging. She struck the seabed at about 1,575 feet, roughly 480 meters down. The 2 men were alive, but they were now trapped on the bottom of the Atlantic in a cold steel ball, in total darkness, with a finite supply of air. Here's the detail that saved them. Before the dive, Mallinson had insisted on topping off their oxygen. That decision bought them time, perhaps 72 hours of it. They rationed everything. They moved as little as possible to slow their breathing. They eked out the chemicals that scrub carbon dioxide from the air. They shared a single sandwich and a can of drink and kept talk to a minimum because talking burns oxygen. Above them, a frantic international rescue took shape. 2 sister submersibles, Pisces 2 and Pisces 5, were rushed to the scene, along with an American robotic vehicle called Curve 3 flown across the ocean. Again and again, the rescuers tried to attach lift lines. Toggles slipped, cables parted in the deep, time drained away with the air. Finally, after about 84 hours trapped on the seabed, Pisces 3 was dragged back to the surface on the 1st of September. When the hatch was cracked open, the 2 men had only minutes of breathable oxygen left. To this day, that recovery from 480 meters remains the deepest rescue of living people ever performed. The same class of robot that saved them, Curve, had years earlier recovered a lost hydrogen bomb off the coast of Spain. Roger Chapman would spend the rest of his career building better rescue systems shaped forever by the 84 hours he spent waiting to die. It is one of the rare survivals in a genre built on total loss. But not every trapped crew could be reached in time. Some faced an enemy that no rescue ship could cut away, an enemy sealed inside the hull itself. Number 3. the K-27. The Soviet submarine K-27 was one of a kind. She was the only boat ever built to Project 645, powered by 2 experimental reactors, cooled not by water, but by a molten alloy of lead and bismuth. On paper, liquid metal cooling was brilliant. It let the reactor pack more power into less space. In practice, it was a nightmare, because if the metal coolant ever cooled too far, it would freeze solid inside the pipes and choke the reactor to death. On the 24th of May, 1968, in the Barents Sea, the port reactor failed. Power dropped suddenly, and radioactive gas escaped into the boat. Fuel elements overheated and ruptured, spraying contamination through the reactor compartment. The crew did not fully understand what was happening. Some stayed at their posts in a space now lethally radioactive. 9 men would die from that exposure in the days and weeks that followed. Many more were poisoned. The boat limped home, but she was finished. A radiological wreck that could never sail again. And here, the story turns from tragedy to recklessness. Rather than carefully dismantle her, Soviet authorities sealed the ruined reactor compartment and, in September of 1981, deliberately sank the entire submarine in the Kara Sea off Novaya Zemlya. They scuttled her in water only about 30 to 50 meters deep. International guidance for disposing of a reactor called for depths beyond 3,000 meters. The Soviets sank a live nuclear hazard in the shallows. They packed the reactors with bitumen and a chemical called furfural, hoping to seal the fuel away from the sea. But the spent fuel still holds highly enriched uranium, and scientists have warned that as seawater corrodes the hull, it could one day expose that fuel, and in a worst case, even restart an uncontrolled nuclear reaction on the seabed. K-27 is not alone down there. She is one of several nuclear objects the Soviets dumped into the Kara Sea in an Arctic that ships now cross more and more as the ice pulls back. Russian and international teams have studied raising her, but the operation is fearsomely difficult and expensive. Her 1968 accident stands as one of the earliest serious naval reactor disasters, years before the world had ever heard of Chernobyl. The idea of a liquid metal reactor was largely abandoned for submarines after her, though a refined version would return decades later on the Fast Alpha class. So she waits, a lethal accident wrapped inside a reckless burial. That is the pattern to hold on to. A submarine can be saved, brought home, and still never stop being dangerous. And danger, as the next crew learned, can also come from a cable on the ocean floor. Number 4. The AS28 Priz. 32 years after Pisces 3, the ocean set almost the same trap. On the 4th of August 2005, a Russian submersible called AS28 snagged on the seabed at about 190 meters in a bay off the Kamchatka Peninsula. This little vessel was itself a rescue craft, a prize-class boat built to save others. Now it was tangled in cables, part of a coastal underwater array, and possibly fishing nets pinned helplessly to the bottom with 7 men aboard. Their commander was Captain Lieutenant Vyacheslav Milishevsky. Their oxygen would last only days, and it was already draining. So they did exactly what the crew of Pisces 3 had done a generation earlier. They lowered the temperature inside, they stopped moving, they waited, and they breathed as slowly as they could. Then something happened that would have been unthinkable during the Cold War. Russia asked the world for help. 5 years earlier, the submarine Kursk had gone down with all hands, while Moscow refused foreign aid until it was far too late. This time was different. The British Royal Navy loaded a robotic vehicle called Scorpio 45 onto an aircraft and flew it to the far side of the planet. American and Japanese teams mobilized too, but the British robot reached the trapped submersible first. For hours, the machine's cutting tools worked at the cables wrapped around AS28. On the 7th of August, the last strand parted, and the submersible floated free and rose to the surface. All 7 men walked out alive after roughly 3 days on the bottom, with their oxygen nearly gone. It was, everyone agreed, the lesson of Kursk finally learned. Timely help, freely offered and freely accepted, had turned a certain tragedy into a rescue. The entangling array, it later emerged, was tied to a coastal sonar defense system, which had complicated the earliest Russian explanations. And Kamchatka's sheer remoteness had added precious hours, since every piece of specialized gear had to be flown in from thousands of miles away. The crew of AS-28 came home. But not every submarine sinks close enough to shore to be found at all. Some vanish within sight of home and stay lost for a lifetime. Number 5. The Minerve. On the 27th of January 1968, the French submarine Minerve was heading back to her base at Toulon on the Mediterranean coast. The weather was rough. She was a Daphne-class diesel boat, and she carried 52 men. She was only tens of kilometers from port, and she signaled that she expected to arrive within the hour. Then, she simply vanished. No wreckage surfaced. No survivors were found. She was gone. The French Navy searched in 1968 and again in 1969, and found nothing. Theories multiplied over the years: a jammed rudder or diving plane that drove her down, a gas or battery explosion, a leak, a collision with another vessel. No one could say for certain, because there was nothing to examine. The loss became one of France's most enduring naval mysteries, made worse when a sister boat, the Eurydice, went down with all hands off the very same coast in March of 1970. Two submarines of the same class lost near the same port within 2 years. For decades, the families of the 52 crew campaigned for a fresh search. They wanted, more than anything, to know where their men lay. That search finally came in July of 2019, more than 51 years after the Minerve disappeared. A specialized vessel called Seabed Constructor, operated by the deep ocean search company Ocean Infinity, swept the seabed with modern sonar and autonomous underwater robots. They found her at a depth of about 2,370 meters, roughly 45 kilometers from Toulon. The wreck was broken into pieces, scattered across the bottom in a debris field that suggested the boat had come apart. The exact failure that killed her is still debated, but after 51 years, her crew finally had a resting place that their families could point to. The French president had personally backed the renewed effort, and the discovery brought a measure of peace that 3 generations had waited for. The Minerve had been lost almost within sight of home, in water that lay far beyond the reach of 1960s technology. And she was not the only Cold War boat to sail into danger in secret. Some went looking for it on purpose, creeping toward hostile coasts to listen and to spy. Number 6. The USS Cochino. The United States submarine. Cochino was one of the first American boats sent to spy on the Soviet Union from beneath the sea. In August of 1949, she was operating in the frigid waters off the northern coast of Norway, near Soviet territory, most likely listening for signs of Soviet nuclear and missile tests. Her mission was so secret that its true nature stayed hidden for decades. On the 25th of August, in the middle of a violent storm, a fault developed in one of her battery compartments. A submarine's batteries can release hydrogen gas, and hydrogen is explosive. It ignited. Explosions tore through the boat, a fierce fire took hold, and Cochino lost power and began taking on water. A nearby American submarine, the Tusk, raced to help through mountainous seas and screaming Arctic wind. What followed was a rescue of extraordinary courage. Over many hours in conditions that could kill a man on deck in minutes, the crew of Cochino were brought across to the Tusk, but the storm demanded its own price. A civilian engineer aboard Cochino, Robert Fillo, died in the ordeal, and 6 sailors from the Tusk were swept overboard and lost while trying to save the men from the burning boat. After about 14 hours of fighting the fire and the flooding, Cochino finally sank on the 26th of August in deep, freezing water where no one would ever recover her. Her commander, Rafael Benitez, was later honored for saving nearly all of his crew against impossible odds. Cochino is remembered as the first American submarine lost in the Cold War and among the first casualties of the long, silent contest of undersea espionage. The battery hydrogen that doomed her was a known hazard of diesel-electric boats, especially when a storm threw them about. But the deeper lesson of Cochino is a bitter one, written 6 times over in the men lost from the Tusk. Sometimes the rescue is as deadly as the disaster. And sometimes a submarine goes down carrying something the world will spend decades trying to reach. In the case of our next boat, it was gold, resting in the deepest dark of all. Number 7. The I-52. By 1944, Japan and Germany were allies separated by 2 vast oceans, and they had a problem. They needed to trade gold and raw materials in one direction, advanced technology in the other. The vessel chosen for one such run was a large Japanese cargo submarine, the AS28 Priz. She sailed for occupied France carrying about 2 tons of gold, along with tin, tungsten, molybdenum, quinine, opium, and raw rubber. The gold was payment to Germany for war technology. Aboard were around 100 people, including technicians traveling to study German equipment firsthand. On the night of the 23rd of June, the Thwar 52 crept toward a rendezvous in the mid-Atlantic with a German U-boat, which was to hand over radar detection gear and a pilot to guide her safely into port. But the Allies were listening. Radio intelligence had revealed the meeting. Aircraft from the American escort carrier Bogue were already hunting. A single torpedo bomber flew from the deck of the Bogue and found her. It dropped one of the war's most secret weapons, an acoustic homing torpedo codenamed Fido, disguised in reports as a mine. The torpedo steered itself toward the sound of the submarine's own propellers and struck home. The German U-boat waiting at the rendezvous, which had come to hand over radar detectors and a harbor pilot, could do nothing. The year 52 went down with everyone aboard, sinking into one of the deepest basins of the Atlantic Ocean. It was Allied code-breaking, the same secret war of intercepted signals that shaped so much of the conflict, that had steered the hunters to that one patch of empty ocean. And there she stayed, untouched, for more than 50 years. In 1995, an American treasure hunter named Paul Tidwell located her wreck at a depth of about 5,240 meters. That is more than 17,000 feet, deeper than almost any shipwreck ever positively identified. Expeditions used Russian research ships and deep-sea equipment to survey the site and to reach for the cargo. But the gold, worth tens of millions of dollars, has never been fully recovered. At that depth, under that crushing pressure, in perpetual cold and blackness, even finding the scattered cargo is a monumental task. The I-52 is a story stacked 3 deep, a wartime spy mission, a secret weapon, and a modern treasure hunt, all resting in the abyss. It is also proof that a submarine's danger does not always end when it sinks. Sometimes, as the reactors on our next wreck remind us, the peril only grows. Number 8. The K-159. Not every submarine dies on a mission. Some die in retirement. The K-159 was a November-class boat, one of the first generation of Soviet nuclear submarines. By 2003, she'd been decommissioned for years. Her reactors were shut down, but they still held their spent nuclear fuel, and that made her a floating hazard even at rest. The plan was to tow her to a shipyard at Polyarny to be scrapped. Because the old hull could barely stay afloat, workers strapped flotation pontoons to her sides to keep her buoyant during the journey across the Barents Sea. On the 30th of August 2003, a storm caught the tow near Kildin Island off the Kola Peninsula. The pontoons that were keeping the wreck alive tore away in the heavy seas. Water poured in, and the submarine sank. 10 men had been aboard to manage the tow. 9 of them died. Only one, a sailor named Maxim Cybulski, was pulled alive from the cold, violent water. The K-159 came to rest on the seabed at about 240 meters, and she carried with her an estimated 800 kilograms of spent nuclear fuel in 2 reactors. The decision to drag a rotting hull across open water on pontoons in uncertain weather was condemned almost at once. Investigations pointed to negligence and a failure to weigh the risks, and the danger did not end with the sinking. The wreck lies in a rich Barents Sea fishing ground. So far, monitoring has found only limited leakage, but the threat grows as the hull slowly corrodes around its nuclear core. Russia has repeatedly studied raising her to remove the fuel before the sea breaks in, working with Norwegian and European experts who share the same Arctic waters. The K-159 came only 3 years after the Kursk, and it deepened public unease about how the Soviet nuclear fleet was being laid to rest. She is one more reactor sitting in the dark, sealed but submerged, a chapter that refuses to close. The reactors on the seabed are a slow danger, measured in decades. But the deadliest reactor story of all unfolded in a single night. And it was survived only because men chose to walk straight into it. Number 9. The K-19. The Soviet submarine K-19 carried nuclear missiles, and she carried a curse. On the 4th of July, 1961, she was running an exercise in the North Atlantic near Greenland and Norway when disaster struck her reactor. A pipe in the primary cooling system ruptured. The pressure that kept the reactor cool began to fall, and the core temperature began to climb toward meltdown. There should have been a backup cooling system. There was not. The early design had left it out. That meant the crew faced a stark choice: do nothing. and the reactor could melt down, or even explode, in waters crowded with NATO ships that might mistake a nuclear blast for the opening move of a war, or send men into the reactor compartment to build an emergency cooling line by hand in radiation fierce enough to kill. They chose to act. Volunteers went in relays, welding and rigging a makeshift pipe to pump water into the dying reactor. Each team could only last minutes before the radiation drove them out, sick and doomed. The men closest to the core absorbed lethal doses. Several would die within days. Others would die over the months and years that followed, but they cooled the reactor. They stopped the meltdown. The boat was towed home, contaminated from end to end, and within the fleet she earned a terrible nickname. They called her Hiroshima. The captain, Nikolai Zateyev, had made a decision no commander should ever have to make, spending the lives of his own men to save his ship and perhaps to prevent a wider catastrophe. The Soviet Union buried the story for decades. It only reached the wider world much later, and in 2002 it became a film, K-19, The Widowmaker. The boat herself was not done. A fire in 1972 would kill still more of her crew. The men who walked into that reactor are remembered as having saved the boat with their own bodies. Their story is the darkest here, and the most human. After so much loss across so many of these boats, you might wonder whether the sea ever simply gives a crew back, whole and alive. Once, in 1939, it did. Number 10. The USS Squalus. The United States submarine Squalus was almost brand new. She had been in service only a few months when, on the 23rd of May, 1939, she made a test dive off the Isles of Shoals near Portsmouth, New Hampshire. During the dive, the main induction valve, a large opening that feeds air to the engines, failed to close. The sea rushed in. Within moments, the after compartments flooded, and the Squalus sank to the bottom, about 243 feet down. 26 men in the flooded rear of the boat drowned, but 33 men survived, sealed in the forward compartments, sitting in the cold and the dark, listening to the water and waiting to see whether anyone could reach them. They released a marker buoy. They signaled. And on the surface, the United States Navy launched a rescue that would change history. The effort was led by Lieutenant Commander Charles Momsen, a pioneer who had spent years developing ways to save trapped submariners. His tool was the McCann Rescue Chamber, a kind of diving bell that could be lowered on a cable and mated directly to a submarine's escape hatch. It had never been used to save lives in a real emergency. Now it would be. Over the 24th and 25th of May, in trip after careful trip, the chamber descended to the sunken Squalus, sealed onto her hatch, took on survivors, and carried them up to the light. Navy divers worked in punishing conditions to make each connection. One by one, all 33 men were brought to the surface alive. It was the first successful rescue of its kind, proof that men trapped on the seabed did not have to be given up for dead. The Squalus was later raised in a long and difficult salvage, refitted, and renamed the Sailfish. She went on to serve with distinction in the Pacific during the Second World War. Her ordeal reshaped submarine safety, from valve design to escape training, and the work of Charles Momsen still underpins how trapped crews are saved today. 10 boats, 10 descents into the dark. And only here, at the very end, does the ocean open its hand and let a crew walk home. Lay these 10 disasters side by side, and the same handful of killers appears again and again. Twice it was a single valve. The main induction valve on the Squalus and the failed air system on Chinese Submarine 361 both let something in or shut something off that should have done the opposite, and both turned a routine dive into a mass casualty in minutes. On the Cochino, it was battery hydrogen, the invisible gas that every diesel boat carries and every crew fears. On the K-19 and the K-27, it was the reactor, the very heart that gave those boats their power, turning on the men who served it. Other boats were caught by the seabed itself. Pisces. 3 and AS28 were both pinned by entanglement, snagged on cables, and pulled down or held fast. The Minerve came apart for reasons still argued over. The K-159 was killed not by combat or accident at all, but by the simple, badly judged act of towing a dead hull through a storm. And the I-52 was found by intelligence and finished by a torpedo that steered itself. What connects them is how a small fault cascades under pressure. A stuck valve, a spark, a cracked pipe, a slipped cable. On land, these are annoyances. Hundreds of feet down, sealed inside a steel tube, they become the whole story. Oxygen becomes a clock. Cold becomes a second enemy. And the margin between an incident and a catastrophe narrows to almost nothing. Every modern safety rule, every backup system and redundant indicator was written in the aftermath of boats exactly like these. To understand why so few of these crews were saved, you have to understand what depth does. For every 10 meters you descend, the pressure rises by roughly 1 atmosphere, the weight of the entire sky pressing on you at sea level. Go down far enough, and that pressure will crush a hull like a can. This is why the rescue of Pisces 3 from 480 meters was so extraordinary. It sat near the edge of what was even possible. Now compare that to the R-52 resting at more than 5,000 meters. At that depth there is no rescue. There is only wreckage, held in perpetual cold and blackness. Between those extremes lies the whole art of submarine survival. A trapped crew is racing 2 clocks at once, the oxygen they have left to breathe, and the carbon dioxide building up around them, which can kill just as surely. Cold water steals body heat and time. Even finding a sunken boat is hard. Rescuers need sonar, transponders, and marker buoys just to locate the target before the real work begins. Then they must get equipment to the spot, sometimes flying a robotic vehicle halfway around the world, as with the Scorpio that freed AS28. Those robots, the Curve and the Scorpio, changed everything, because they could work at depths, and for durations no diver could match. Notice, too, that a shallow loss can be just as lethal as a deep one. Chinese Submarine 361 sank in only tens of meters of water, and it made no difference at all because the crew were gone long before any rescuer could have reached them. Depth decides whether a boat can be reached. It does not decide whether the men inside are still alive to be saved. The march from the McCann chamber of 1939 to the robotic arms of 2005 is a march measured in lives saved. But the gap between detecting a crew and actually reaching them has never fully closed. 2 of these boats are more than history. The K-27 and the K-159 are still down there, and they are still dangerous. Each holds spent nuclear fuel, including highly enriched uranium, sealed for now behind corroding steel. The K-27 was scuttled deliberately in the shallow Kara Sea in defiance of guidance that called for far greater depths. The K-159 sank by accident in the Barents Sea in the middle of a fishing ground. Both sit in Arctic waters that matter more every year, as retreating ice opens new shipping lanes and as fleets work the seas above them. The K-159 alone carries an estimated 800 kilograms of spent fuel in her 2 reactors, and she rests at just 240 meters, well within reach of the sea's slow chemistry. The fear is not a sudden explosion. It is slow leakage, radioactive material seeping into the water as the hulls give way over decades. There's a real difference between a shipwreck and a waste site, and these 2 boats are both at once. Monitoring has so far found only limited contamination, but the timeline runs against us. Russia, Norway, and European partners have all studied the enormous task of raising these wrecks to remove their fuel before the sea does it for them. It is a reminder that the Soviet nuclear fleet was never fully laid to rest. Some of it was simply sunk and left, and it is waiting still. Strip away the machinery and the physics, and every one of these stories is about people. It is about the volunteers on the K-19 who walked into a radioactive compartment knowing what it would cost them, and did it anyway to save the boat. It is about the 6 sailors from the Tusk swept off the deck into an Arctic storm while trying to rescue strangers from a burning submarine. It is about the 33 men of the Squalus keeping their discipline in the cold and dark, and the crews of Pisces 3 and AS28 lowering the temperature and slowing their breathing, buying themselves hours 1 shallow breath at a time. It is about commanders like Nikolai Zateyev and Rafael Benitez, forced to make choices no one should have to make. And it is about the 70 men of 361 who never had a chance at all. For the families, the cost often outlasted the disaster by decades. The relatives of the Minerve's crew spent 51 years not knowing where their men lay before the sea finally gave up its answer. Recognition, when it came, often came late. But the quiet professionalism runs through all of it. The divers, the robot pilots, the crews who chose to help. These boats reveal, more than anything, what courage looks like under the sea. 10 submarines, and only one crew walked home whole. That is the arc of this story, from the silent total loss of 361 to the triumphant rescue of the Squalus, with 9 tragedies and a handful of near miracles in between. The ocean, it turns out, preserves machines far better than it preserves the people inside them. It kept the intact hull of a Chinese boat and let its crew slip away. It swallowed a cargo of gold and holds it still. The deeper lesson is that the danger never truly ends. A boat can be saved and remain lethal, like the AS28. A submarine can die in retirement, like the AS159. Reactors sit on the seabed even now, sealed but patient. Wrecks like the I-52 rest beyond any hope of reaching them. And yet men keep descending, keep building better valves and better robots and better ways to bring each other back. The darkest trenches keep their secrets. They hold the lost, and once in a great while, they return the living. Somewhere in that narrow space between the two lies every reason we still go down into the dark, and every reason we should never forget the crews who did not come back up.